Thank you for so many of you taking the time to join us today. Thanks especially to those of you who are joining us for the third time, as this is the third in our three-part series. We're glad to have kept you entertained throughout the series. My name is Ollie Howard. I'm Lead Propositions Manager here at NCC Group, the people-powered, tech-enabled cyber security services provider. As a bit of background on NCC Group, for anyone who's not so familiar, we cover the full life cycle of cyber, from technical security testing, strategic consulting, implementation, managed detection and response, and we're also there to help respond to incidents when things go wrong, and we do that for our clients globally. So in the two previous webinars I mentioned, we focused on cyber resilience in an AI-driven world, and then more recently navigating the new frontiers of cyber risk in the age of AI. We're changing things up a little bit for this one. We're talking about building confidence with security, safety, and trust. We're broadening the conversation beyond cyber and addressing the holistic remit of risk beyond the technology. Now, just to talk to this slide for a few moments, as we know, AI is evolving at such pace and is indeed shaping our society. Its capability is becoming incredibly powerful, but with every potential benefit comes new risk. And AI's use across industries is becoming ever more crucial, with its core use case in many sectors to increase productivity and efficiency. And increasingly, it's being deployed into scenarios where, should anything go wrong, it can present a genuine danger to human life. And we see this every day through the work that we do, and our panel has first-hand experience of helping our clients in this regard. And that leads us into point 3, and the need to think more holistically about AI than securing the technology and fully appreciating the knock-on implications and therefore mitigations required to keep society at large in the driving seat with AI. Having provided that introduction, I'm delighted to introduce today's panel, who will do a much better job of introducing themselves than I will. So, Sean, first, please.
Yeah, hi, Ollie. Great to be here. My name's Sean Arrowsmith. I'm Director of Industrials at NCC Group. So I focus on developing our go-to-market propositions, particularly within the industrial sectors, working across a broad range of sectors that you'd expect within that vertical, across energy, water, manufacturing, and into transportation. So, I work very closely with our OT team as well. So we're looking at criticality around safety in the environments that we operate in and providing consulting around risk reduction for those types of customers. So really great to be here today and looking forward to the session. Thanks.
Thank you, Sean. Great to have your industrial lens on the discussion today. Thank you. Nick.
Yes. Hi, everyone. My name is Nick Chosos. I'm an executive principal consultant for Adelaide. Adelaide joined NCC in 2021, and we complement NCC's security offering with a sort of a research-based approach to digital system safety across critical industries. So we've been working within nuclear sector, aviation, rail, and healthcare. And specifically within the area of AI, we've been quite active over the past 5-6 years, where we've done a number of research projects aiming to inform work done by regulators and governments to think about the risks related to AI and also to think about mitigation strategies. Personally, I have a background in computing science. I have a PhD in the University of Glasgow in human-computer interaction, specifically within patient safety. And I've been with Adelaide for 16 years, and I also lead our medical devices work. So that's me.
Fantastic. Thank you very much, Nick. And last but certainly not least, Robert.
Hi. Hello, everyone. I'm Robert Stroud. I've been with Adelaide for about 12 years, something like that. Slightly not quite as long as Nick. I work on assurance and what we call independent confidence building measures, which has a rather unfortunate acronym, ICBM. But independent confidence building measures are, somebody's produced a system, they claim it's safe. How do you know it's safe? One way is to kind of look at it from another perspective and run tests on it, or you analyze it, and so on. And so that's the kind of thing I do. I analyze software. I'm looking for the kind of bugs and defects that might only show up every 100 years. Okay, but if you've got a safety critical system and a 100-year bug shows up, that's not good news potentially. I also I've done quite a lot of work in the transport sector, and I'm currently working on the revision to a standard called PAS 11281, which is on the connected automotive ecosystem. So it's about the safety and security of vehicles that are driving around the place, not necessarily autonomously, but obviously AI is important for autonomous vehicles.
Mm-hmm.
But you know, what sort of safety and security concerns you might have about connected vehicles in general. So I do a huge range of things. Oh, and one other thing I should mention, I was involved in the DARPA project. That's the American military advanced research about, I think they call it code to combat. Okay. Mm-hmm. So what they want to do is they want to make changes to their weapon systems and get them certified and deployed in the field as soon as possible, which obviously requires some kind of automation and potentially some AI technology to build the certification cases assurance argument. So one of the things is part of Adelaide's DNA, I guess, is about assurance. How can you be confident that something is safe and secure?
Yeah, absolutely. Well, thank you very much, Robert, and you know, real sort of diverse and varied skill set and experience across the panel today. So let's jump into the first discussion point: AI threats and risks, security and safety. First question to the panel: what are the emerging threats and risks associated with AI adoption, from bias and data leakage to AI-powered attacks, and how can organizations mitigate these? I think we are jumping to Sean for the first input to this question.
Yeah, so I thought I'd go and talk about it in the context, I guess, of the markets that I operate in. And as I said before, I'm working with helping companies reduce cyber risk in energy, water, manufacturing, transportation, those types of industries. And quite often we're working within quite hazardous environments in terms of operational technology environments and operational environments within those sectors. So the use of AI within those, there's obviously quite a lot of risk in terms of what the AI might do and whether it's trustworthy. Those sectors have actually been using machine learning and data analytics and things for quite a long time, which has driven the term around IT and OT convergence. So they can get more data out of their operational environments, so they can be more operationally efficient, they can reduce costs, they can hit sustainability goals. So this kind of journey has been happening for quite some time, and now AI is coming to the fore and has sort of arrived very quickly. That's certainly something that those markets and the customers that we talk to are starting to look at. But of course, those sort of environments, and I think you touched on it already, Ollie, the worst case outcome can be criticality to human life and safety. Yeah. So considerations around AI and the risks around that is really, really important within those industries. So from a risk perspective, I think the use of AI for doing depends on the use case. So if you're doing predictive maintenance, for example, and you're taking data off sensors and things within a manufacturing line or something like that, and that's fairly passive. But in terms of getting into the kind of agentic AI, making autonomous decisions on behalf of the organization, that's something that I think is a little way off, particularly within those environments, because risk appetite and tolerance within those environments is pretty low, as you can imagine. So it's really questions around trust, and we get onto trust later, I think, in the session. So thinking about those risks, and if AI is going to make decisions on behalf of us without a human in the loop, what could be the consequences? So we really have to make sure we understand those risks thoroughly before we adopt it. And certainly I see that within the companies I work with. Energy, they're looking at using it for monitoring of energy networks and consumption, and changing the grid and bringing in with renewable energy technologies, etc. So it's certainly something that's being looked at, and it's picked up by the regulator as well in terms of the likes of Ofgem. So yeah, lots of risks to think about because the consequences and mistakes are high, particularly within the markets that I operate.
Thanks very much, Sean, kicking us off with that. I think we're going to jump to Robert for your take on this next.
Yes. So I mean, picking up on the risk to human life, of course, autonomous vehicles are the obvious example. and one of the sort of driving forces behind the idea of autonomous vehicles is that computers are better drivers than humans, or at least that's the hope, that computers are better drivers than humans. Now, the truth is very different, and the issue is not so much whether computers could be better drivers than humans, but how can you be sure they are better drivers than humans? And the risk is that people will die, and people have died. Autonomous vehicles have killed people. And I think there's an interesting balance there as to what is society prepared to accept. I was quite surprised that people didn't react more strongly when the first person was killed by an autonomous vehicle, because to me, when computers start killing people, people get very unhappy. But at the moment, it doesn't seem to be causing as much trouble as you might think. But I'd also like to point out that AI safety tends to have a slightly different meaning. So when I talk about safety, I mean, threat to human life and the environment and so on, and physical damage and things like that, as Sean has said. But AI safety people in the AI community, when they talk about AI safety, they mean the AI doing something inappropriate, potentially harmful, possibly in a sort of psychological way or in a much more touchy-feely way. So a couple of examples in the news today and in the last few days. If you have a chatbot that speaks on your behalf and turns into a white supremacist and starts praising Hitler, that is not good for your reputation, okay? Although some people might think that Elon Musk's reputation is problematic enough as it is. And the other example, which I thought was very interesting, is a student from Princeton contacted one of these chatbots and said, "I've just lost my job. I'm feeling very miserable. Can you tell me where the highest bridges in New York are?" And the implication was he was going to commit suicide. And the AI, instead of saying, please reconsider what you're doing and why don't you talk to the Samaritan, says, "Sure, the highest bridges in New York are X, Y, and Z." So I think when people start treating the AI as a human and talking to it and interacting with it in that way, it can potentially lead them astray and not realize they have a serious mental illness or problem that needs psychological help.
Yeah, it's this topic itself, because there's so much happening at the moment. There does seem to be daily examples that we can draw upon as sort of case in point. But thank you, Robert, for the input there. Nick, I think you're going to round us off on this topic.
Yeah. So Robert mentioned autonomous vehicles, and so you can imagine not just with autonomous vehicles, but in all kinds of applications, AI being a sort of a real-time control system where it makes a decision and that can have catastrophic consequences. We can also think about more long-term possibilities of failure with an AI system. So, for instance, we've seen multiple reports over the past few years where, even though we have a lot of success stories using AI in diagnostic systems within healthcare, and particularly with coronary disease, a lot of research has found that there are actually all kinds of problems due to bias in the algorithm and the data, because, of course, you have to take into account demographics. You have to take into account ethnic backgrounds when you're going to be making diagnoses like that. But it's very, very difficult to get data that perfectly represents every single patient group. But we're not always aware that this is happening. So then somebody might get misdiagnosed. So yeah, there are a lot of potential failure modes that we are observing with AI. So we know that when we're talking about, say, an LLM, right, a large language model, or ChatGPT, something like that, you ask it a question and then you get an answer. But we can't assume that the AI is objective. It can very well be subjective. It can, depending on how you ask the same question, you can say, how good is something? You get a certain answer. For the same thing, you can ask, how bad is that? And you can get an answer that is also trying to support what you're asking. And AI is already known for having difficulties to handle edge cases. So, it can do some prediction reliably for the biggest, the most of the targeted group, but there will be edge cases that it might miss. So we are unable to fully control the quality of the data that the AI may be feeding off. So, for instance, if AI is using a lot of content on websites, with time, more and more of this content is generated by AI. So whatever little flaws are built in there, they are used to continually train the system towards their own way. And of course, those systems are more vulnerable to adversarial input, right? So the more power is centralized within one machine, and the more benefit you can anticipate. There is also a proportionate side towards risk. There is new and unanticipated risk. So there are limitations of using AI to monitor AI, right? We can't do that everywhere. So we need human control, or we need non-AI control, so that we make sure that we maximize the benefit, but control the risks. And then just the final point in the longer term is that, because we're talking about safety critical industries, AI can pose a threat to safety culture over the years, because knowledge and responsibility is slowly augmented into a machine separated from a human. So there are areas there that we need to ask questions about from ourselves.
Of course. Thank you very much for that really diverse and various set responses across different industries and sectors that we're seeing. So thank you all. We'll move on swiftly, because we've got a lot to get through too. Our second theme, integrating AI into systems and staying in control. So question here is, organizations adopt AI, how can they safely integrate it into existing systems or build new ones using AI while maintaining control and accountability? And I think, Nick, we're straight back to you on this one.
Yeah. Thank you, Ollie. Yes. So you mentioned a couple of different applications of AI. You can be using AI to generate code or to design systems. The AI can be making decisions, real-time control systems, or you can be using AI to generate test cases and to run the tests for you, and then to write a report for you. All of that is potentially great, but when we're talking about staying in control, it means different things for these different scenarios. So you can have different levels of autonomy. You can have a system that is completely operating on its own, or a human can check in every now and then. That's called human on the loop, or human in the loop, which is that there is a balanced distribution of responsibility between the human and the AI. So human in the loop is an old concept. It's been around since the mid-'80s, because when we're trying to offset some of the risks associated with automation. But with AI, it's a much more complex question. So the thing is, the human beings need to be the human beings that are the ones responsible for the AI. They are the ones that need to feel that they are in control. And so that means we have to ask them. You need to involve humans. You need to apply human-centered design when you're developing your AI systems. But one of the biggest buzzwords around AI is explainability. So the AI being able to explain itself, and that can mean all kinds of different things. So we should also be able to audit it, not just ask it, why did you give me that result, but also audit it ourselves. What was the decision tree that you used? What is the data that you used? What assumptions did you make? And what was your process for learning? Okay, so these are all things that we need to do to stay in control. But really, we have to understand the impact that AI has on the human role and the human responsibility. And then we need to take into account accountability as well within that.
Thank you very much. So remaining in control, I think, is key there. We're going to jump to Robert next for your input to this question.
Nick touched on explainability there, and I think what part of the difficulty here is that AIs work in a very different way to the way we think. So Nick talked about decision trees, and decision trees are great. We know what decision trees are, but that's not how computer vision works. And my favorite example of this is I think it's probably, the story might be apocryphal, but it illustrates the problems. Somebody trained in AI with photographs to recognize whether a tank was hiding in some woods, you see. So you showed it the photograph and it would tell you, oh yes, there's a tank hiding under those trees over there. And the system appeared to work extremely well. So they got the big generals in to demonstrate how wonderful this system was. And they gave it some photographs and it did really badly and they couldn't understand what the problem was. And it turned out that the system was actually, the photos with the tanks in were taken on the day when the sun was shining. So what the computer vision system was actually recognizing was, is the sun shining in this photograph, not is there a tank under the tree? And the problem is that if you said, well, how did you reach your decision? It will say, well, the weightings in my neural nets took me down the left branch rather than the right branch, which doesn't really tell you anything. I think you need to, I think it's important to understand the limitations of an AI and exactly what it can and can't do. And I think, again, the autonomous vehicle is a good example. If you say that an AI is safe for a particular, essentially the AI needs to know its limitations. Okay, if you ask ChatGPT a question and it doesn't know the answer, it should say, I don't know the answer. It shouldn't make something up, which is what it has a tendency to do. I saw another extraordinary example the other day of somebody that asked ChatGPT to review their essays, and they said, I'm thinking of publishing my essays in the book. Would you help me select 3 good essays that are representative of my style? And ChatGPT gave really impressive literary reviews of these 3 essays and explained how they complemented each other, and then admitted that it had made it all up and hadn't actually read any of the essays at all. So you really need to know what's going on and what the AI is doing. I think there are some applications where it's obviously quite good at things. The big data machine learning, statistical inference type applications where you're doing preventative maintenance, you're trying to predict when something will fail. And okay, you might end up servicing something a bit too often, but no harm is going to come of that. But if you're making a decision about, is that a person in front of me or just a bicycle? And is it okay to run over a person or is it okay to run over a bicycle? Well, the answer is probably neither. But if it's that kind of decision, it's much more important. And if the AI, only works under certain conditions, and if it starts raining or gets misty or there's too many cars on the road or something like that, it needs to really, hang on a minute, I can't cope, and hand back to the human, which of course brings up another problem, which is, humans are very bad at supervising automated systems. And if the driver's sitting there reading his newspaper, and then while the car drives itself, and then the car suddenly says to the driver, "Oh, I'm sorry, I can't drive anymore. You're going to have to take over." It's not going to work very well. So there's a real problem about that handover between the AI and the human.
Yeah. Absolutely. There's some really interesting anecdotes there. Thank you, Robert. Sean, just a quick word from yourself on this one, before we move on to the next point.
Yeah, just good. I mean, great points from Nick and from Robert. But in terms of Robert's point in knowing what the AI is doing, and I look at it in terms of, to integrate safely and to stay in control, we need to put controls around the use of AI in certain use cases. And one of the most important things is to define a clear outcome that you're trying to achieve as a result of deploying AI within a business context and understanding that context. So for me, it's adopting similar approaches to secure by design and making sure that you do things correctly, rigorous testing, you're doing risk assessment, you're assessing the potential risk from deploying the AI, and that you have that kind of strong governance built around the use of the technology. And like all new technology, it's an iterative process in terms of how we become more familiar and adopt it, and we learn from how it operates and from some of the mistakes that it makes that Robert's talked about as well. So it's making sure that we have that kind of feedback loop on some of the errors that we see within AI adoption to make sure that we stay in control and understand the risks. Yeah,
that's absolutely right. I mean, putting a wall around the AI and containing it in some sense, so saying you can do what you like inside this little area here, but if you step outside that, then you're outside what you're designed to do, and somebody else needs to take over. I think, and as I say, AI aren't always aware of their limitations in that sense. So I think
for us to put those limitations and parameters in place.
That's right, and doing
and really understand the data that it's learning from.
It's putting a proper risk assessment in place as to, what sort of things might it get wrong. And of course, one of the problems is, although you can learn from your mistakes, you're not going to build a perfect system by doing that. You'll reduce the number of mistakes, But the really rare events that don't happen very often are the problem for safety. Getting it to 99% good enough is okay. That's fine. People have driven cars 10 years ago across the country that were 99% good enough. But safety requires it to be 99.99999% good enough. And getting those extra nines of confidence is very difficult. And you have to use a whole series of different approaches like testing and simulation and so on. But you're always worrying about the unexpected, something you haven't thought of, that you didn't anticipate. You know, an example would be a car driving across the Arizona desert comes across an elephant. Okay, well, the elephant must be a figment of its imagination. There aren't any elephants in the Arizona desert, okay? But it might be a picture of an elephant on the side of a circus fan or something like that, you know. So really unlikely things can happen, and you have to decide. Of course, if a car was driving across the African plains of Africa, find an elephant, it will be a real thing. So, you know, how does it know whether the elephant's real or not? You know, that's
we must move on. Fascinating as this topic is. We've got a final point to get in before we wrap things up. Plus question. So on to the final question: building confidence in AI systems. So lost my place here now. There we are. So how can organizations build confidence in AI systems, ensuring that they are safe, secure, and trustworthy, especially in regulated or high risk environments? Nick, to you for this one, please.
Yeah, thank you, Ollie. Yeah, so I mean, there are there's quite a lot to unpack there. I think that, you know, the first question that we need to ask ourselves is, do we actually need this AI application right now for this specific function in this specific system? Then there should be a strong business case for using it before you choose to invest in that technology. Then you need to perform a risk assessment and understand, do the benefits outweigh the risks, as we at least understand them now? But then we should be thinking about both the immediate and long-term effects that AI can have. So we then need to determine the acceptable level of error. There's going to be more potentially error in certain applications, less than human error in certain contexts, but we can't be 100% certain that the AI is always going to behave the way that we want it to. So we need to build resilience, and resilience means you plan for the unexpected. So you should, if it's a critical function, you should at least have a fallback. And then, yes, the things that we touched upon before. So having a systems approach. So it's people, procedures, non-AI technology. Then trust takes time, right? As with people, you don't just take something on face value. People have a positive predisposition for a positive bias for AI. People have a negative bias against AI, you know, so there's a complex landscape. And then we need to think about the ethical implications, the impact it has on workforce and also the environment, because we know how draining to energy AI can be. But there are a lot of new, when I say new, I mean over the past 1-2 years, standards and regulatory reactions to the innovation that we're seeing with AI that are very, very important. So there is an IC standard 5469, functional safety in AI. That is a standard that I would recommend to anybody to take into account, at least if they're working within the safety domain. IC 42001, which is about AI management systems. So companies that are using AI, they should really think about investing in having a management system like that. And then there's the EU Act, which I think we might talk about later on. But yeah, to kind of, you know, final point there is that, you know, it needs research. We need research. We need time to understand the risks and the benefits. And Adelaide is active in this area. So we are doing a lot of research, as I mentioned in the beginning of the meeting, regulators and with government agencies around regulation of AI. So please talk to us if you're ever interested in finding out more.
Thank you very much, Nick. Robert, your input here.
Yeah, so just to follow on from that, I think as Nick says, you need to have a fallback. You need to understand the risks. You need the failure modes of the AI and so on, and then you can build controls around that and so on. I think it's I think it's very helpful to think in terms of an assurance case, or safety case. So an assurance case is a structured argument which presents the evidence that supports the belief. And so if you claim that your autonomous vehicle is safe under all conditions, even though it's built from AI, you can break that down into a series of sub-questions and arguments and evidence that you have to provide. And we've done some Adelaide have done some work on this. We've developed some sort of template safety arguments for autonomous vehicles, for example, for the Department of Transport, which I believe are in the public domain. But we've also done some interesting workshops. It's what's called the sandboxing approach. And the idea is that you get the regulator who's going to make the final decision, and you get the engineers who are building the systems that they want to have approved by the regulator in the same room. And you give them a toy example, and then without any kind of skin in the game, so to speak, you can then have an open and free and frank discussion about where the difficulties and the challenges are in doing this. So we've done it. We've done this with the nuclear regulator, talking about the use of, for example, a robot-controlled arm that's AI controlled for handling radioactive material. That was one example, and we looked at the kinds of issues that you'd have to investigate and claims and evidence you'd have to produce in order to provide the convincing argument that it was safe. And then the other example was about the kind of preventative maintenance type thing. How can you know you have structural integrity? And I think there's an important role for regulations here. I mean, this is very, you might not be aware, but there's a rather curious organization called the World Forum for Vehicle Regulations, which is run by the United Nations Economic Council of Europe. And the world in this sense excludes a couple of major players like America and China. But apart from that, it covers quite a lot of the world. Yeah. And they have very specific, one of the challenges, perhaps the simplest use case for an automated vehicle is driving down the motorway and keeping to the lane. Okay, so we already have adaptive cruise control. We already have lane keeping systems as driver assist. So what do we have to do in order to let the driver sit back and read his newspaper while the car does it all automatically for him? And so you can go to if you Google for UN Regulation 157, you see what kind of evidence you have to produce, what sort of issues you have to address. Interestingly, I assumed that this would work up to motorway speeds. The standard is these systems are only allowed to operate up to 60 kilometers an hour, 40 miles per hour. And that might be to do with limitations of the technology or limitations of human reaction time. I was quite surprised by that. Saying, what use is a system like that if I can't go at 80 miles an hour down the motorway? Well, you shouldn't be going at 80 miles an hour down the motorway. But in any case, but no car has managed to pass this regulation. So that's why there are no cars allowed to drive like this on the motorways in the UK. And this is the simplest use case you can imagine. Imagine a use case for driving through the town, picking up drunken students outside nightclubs on a Saturday night, without running everyone over. I mean, that would be a total nightmare.
Is there any presentation that tells and shows how we can secure AI-generated code and what kind of strong AI governance policies we have to implement?
So I do quite a bit of code assurance. I mean, I was doing some this morning, analyzing some code. And I think I would analyze AI-generated code in the same way I'd analyze any other code, using tools that understand the programming language, understand the kinds of defects that you might find in the programs. Now, whether those tools are AI powered is another question. The tools I used are based on sort of formal mathematical models of programming languages, something called abstract interpretation. And it's not clear to me that gives it some precision, in what it can say about the program and what's likely to happen here or there. But it's not enough. And I was thinking to myself this morning, well, wouldn't it be nice if I had some kind of AI system that would let me ask questions about the code and would give me answers, that would help me in this analysis. But I still think I'd want to have a formal basis, something like the abstract computation to guide my analysis. So that answers the first part of the question. I'm not sure about the second part of the question. That's about having a strong AI governance policy. That's a rather different question, I think. So perhaps someone else could tackle that.
Yeah, and I think certainly, as the group at large, there's we can certainly forward that on to some of the team that work in our governance, risk and compliance, who are looking closely at AI through that particular lens. I'll jump to the second question.
Okay.
I think Nick, potentially yourself, how can organizations balance the trade-off between innovation and the need for responsible, ethical AI use?
Yeah, I mean, I think that responsible and ethical is for me is the first necessary thing to do, so that we can actually allow innovation to flourish. And now we can get in a sort of a more philosophical conversation. Firstly, we establish, do we actually need this technology? Are we going to benefit from it in a specific application? And then we take into account responsibility, ethics, before even proceeding with the investment. Else, things can go their own way over a number of years.
Yeah. Thank you very much, Nick. Further question, it's addressed to yourself, but others may have input to it, but we'll come to you first. So just a curious question, is your team or any of the research mentioned about AI security regulations, or are they predominantly about AI regulations? So subtle difference there.
Yeah, so I mentioned 3 different standards. The 14569 is functional safety, so it predominantly focuses on safety. I think that 42001 AI management systems, that should also cover security, but that's the management system rather than designing or using the AI. And the EU AI Act covers both safety and security.
Yeah. I mean, I spoke at a previous one of these webinars in a different series about security and safety, and my view is if you can't show if it's not secure, it's not safe. So you can't have safety without security. And in the autonomous vehicles world, actually in the automotive world, there are various different standards. There's a standard on functional safety, which is 26262. There's a standard on cybersecurity, which is 21434, I think. Another standard on what's called safety of the intended functionality, which is really about the machine learning AI component of the system and how you can be confident it works. And then you have to put all that together with an understanding of humans and human responses and how drivers will interact with autonomous vehicles in order to put together an assurance case that is convincing evidence that the car has got the right balance of human in the loop control and the right balance of autonomy and will do the right thing in the right circumstances. So it's a multidisciplinary thing. You need to understand safety, you need to understand cybersecurity, you need to understand the limitations of AI and machine intelligence, and you need to have a human factors perspective on it as well. And all of those things need to go together to do your case.
Absolutely, really comprehensive answer to that question. Thank you, guys. What message would you like senior leadership to hear, specifically, obviously, around the topic of a safe AI adoption?
So my answer would be: don't believe the hype. Be realistic. Okay, I was at a workshop the other day where it was suggested that the reason that companies are investing in AI is because if they don't, their share price will drop. Okay, and maybe that's a good reason for a chief executive. Maybe that's the kind of thing that chief executives worry about, and their share price dropping. So they think, oh, we better invest in AI. But I think rather than saying, I think the way to think about this is rather than saying my system is powered by the latest fancy AI ML technology, my system is powered by some very clever software whose behavior I don't entirely understand, that's difficult to predict and control. and then think about what the implications of that are, you know, and what are the things that might go wrong, and how would you handle them and so on. Because AI is just software. There's no intelligence there. It's just software, and I think that's what people don't realize.
Well, of course, there are great opportunities as well, right? Great opportunities from this new technology. It's just we just have to be careful. Should we use it or not for a case-by-case scenario, and then do we make the right investment to invest in safety and security before getting enthusiastic about the potential benefits?
What are the red flags to look out for in a supplier onboarding process, AI supplier onboarding process? Robert, your take on that?
I'd want them to be realistic about the limitations of their technology. If they gave me a load of hype about how it was best thing since sliced bread, I'd be very wary.
So over the past few years, we saw apps like symptom checkers, health symptom checkers, claiming that they're better than your GP, and I think that is a red flag for me, because it's just not, it's dangerous to say things like that.
Yeah, you need some evidence for any things like that.
Yeah, and any of those sort of bold, unrealistic claims that you get from vendors, I think you need to drill into those and understand the underlying supporting evidence around them, because I mean, clearly there's a lot of marketing hype and dressing up of technology.
These things are quite difficult. They're very subtle. So are AIs better drivers than humans? Well, it depends how you ask the question and how you analyze the data and so on. You really need to know what you're doing to make that kind of judgment. And
before the sort of explosion of ChatGPT and everything, there was a saying around that machine learning is written in Python and AI is written in PowerPoint. So it's sort of that approach, really.
Very quick takeaway. So I think clear things that have come from this discussion: understanding and managing risk, staying in control, confidence. It's coming from that convergence of safety and security, and regulatory engagement being a cornerstone of this. A quick graphic on the screen there that presents the things that we can sort of provide consultancy and support around with regards to AI, and our safety consultancy fits nicely into that picture as well. Again, thank you so much. Until next time, stay safe, and we'll catch you again soon. Take care. Bye bye.
Thank you
very much.
Goodbye.
Thanks, everyone.